Vishal, with your golden and turn on. That room AC turn off, huh? Okay. Only you turn on that AC, this I don't want. Okay, very good evening, students. Comfortable, huh? Glaring, huh? Non-glaring zones, use it.
This side, that side.
Okay.
This corner.
Okay. No issue, no?
No issue.
Okay. So I will send you weekday people early. Transformer. Okay. That is actually a transformer in the EMI, electromagnetic induction. I will finish it. Questions, JEE mains level questions will come. Advanced, no chance. Okay. So listen, in the watch this device name transformer. What is the meaning of that? The device which will transform the voltage. Okay. When you are, for example, in the PPC means power production center, what is the power produced by the power production center? It is around 1 lakh volt. I mean 10 power 5 volt will be there. Sometimes 2 lakh volt also. Understood? Very high voltage they will produce. But in your house, in your house, all equipments in our India, what is the tolerable voltage? 230 volt. In America, 250 like that. Correct or not? Directly, this much 1 lakh voltage potential difference. Directly, if you are giving to your fan, refrigerator, what is their situation? What is their future? Gone. Your total building will be shorted. Correct or not? Short circuit. Over. Understood. Okay. So in that, no doubt. That's what we need to do. You should step down this voltage. Understood or not understood? That's what in every street there is a step down transformer is there. In that step down transformer, what will happen? These high tension wires like 40,000 volt, 50,000 volt high tension wires will enter into this step down transformer inside your street, and it is converting into 230 volt, and it is making from high tension wire to low tension wire. So every transformer in your street is called a step down transformer. Which transformer? Step down transformer. Understood? That is the, substation role also same thing. Every city substation is there, na? Substation, for example, one rough example, one mini hydro power station is there. It produced around some 10,000 volt potential it is producing. Correct or not? It has to reach one SS substation. Substation means every city, every town, in the outskirts, substation will be there, na? Correct or not? So in the substation, in the form of high tension wires, current will come. Understood? Here 10,000 volt if you send, no, very large amount of energy will be wasted. That's what at power production center, 10,000 volt to 50,000 volt, you have to increase it. When electrical energy transmitted at high potential only, lots of energy dissipation, you can avoid it. Understood? So at power production center, what type of transformer you will use? Step up transformer. Understood? I think you understood what is the use of the step up transformer. What is the step down transformer? What is step up transformer? That is used in only power production centers only. Where would you use step down? In our streets and at the substations. Is my point clear? Let us see how this transformer will function. So for your understanding, I will explain step up transformer only. First, let me describe the basic construction of the step up transformer. It containing two inductor coils. How many inductor coils? Here one self inductor, and here one more self inductor. How many coils are there? So the transformer working principle is, everyone knows, mutual induction. What is that? Mutual induction. So this left coil is called primary coil. What is the name of the left coil? Primary coil. What is the name of the right side coil is? Secondary coil. Secondary coil. So for suppose this is your PPC, means power production center. Average I am telling, here 10,000 volt you are giving here at the primary coil. What is your aim of this step up transformer? At output you have to get 50,000 voltage. That is your target of the step up transformer. That's what in the primary coil, less voltage you have to take, and output you have to obtain more voltage. You know what is the active inductor? Original current is flowing in the left coil only, na? You applied original EMF at the left coil only, primary coil. So original current is flowing in the primary coil. The current flowing in the primary coil is IP, primary current. How much EMF you applied is called what here? Primary EMF. How much voltage drop you are obtaining at the secondary coil is secondary voltage. Understood or not understood? Yes or no? And as you placed these coils very close, what will happen? This inductor is acting like a bar magnet. It will produce magnetic field lines. Some magnetic field lines also passing through the secondary coil. Says or no? This is AC current only, na? AC means what? Alternating current. I mean, current will always changing. Current changing means flux also changing, na? Kindly say yes or no. You applied primary current how much for suppose? I naught into sine of omega t. Now tell me what is the EMF induced across the primary coil? What is formula? L1 into dip by dt only, na? Correct or not? So put this IP value here. So EMF induced in the primary coil how much? L1 into d by dt of IP value how much? I naught into sine of omega t. So L1 into I naught value how much? I will take it outside, and omega into cosine of omega into t. This is a EMF induced in the primary coil. Understood or not understood? What is the L1 value? Who will tell coefficient of self-inductance formula? Mu naught into n square into A into L, or mu naught into total number of turns and into A into L by L. 1L will be there. Correct or not? Okay, so that is a coefficient of self-inductance. And according to Faraday's law, what is the EMF induced in the secondary coil? Tell me. Original current is only changing in the primary coil, but also as you place the secondary coil very close to the first coil. What is the EMF induced in the secondary coil? Tell me. What is the formula? Mutual induction and how much? Di by dt, or change in flux in secondary coil divided by change in time taken. What is the total flux change in secondary coil? Number of turns into magnetic field produced by first coil into area of the second coil. Yes or no? Have you noticed the EMF induced in the secondary coil is what here? Proportional to number of turns. Correct or not? This is the working principle of the transformer. Now I hope you understood. Applied EMF, I mean EMF induced in the inductor is directly proportional to total number of turns. Which primary coil is having more EMF? Secondary coil only, na? That's what number of turns in the secondary coil is more. Understood? So I will write down some conditions for step up transformer. Conditions for step up transformer. What is the first condition? EMF induced in the secondary coil must be more than EMF induced in the primary coil. And also number of turns in the secondary coil is more than number of turns in the primary coil. But if it is idealized transformer, nothing is ideal, na? Nothing is ideal. If you assume this transformer is an ideal transformer, means how much input power you are giving, same output power you have to obtain. So I can write one statement for ideal transformer. For an idealized transformer, I could write one statement: input power equal to how much? Output power. Who will tell input power formula? EMF induced in the primary coil divided into current induced in the primary coil. What is the output power? EMF in the secondary coil into current induced in the secondary coil. So I can also write EP by ES is equal to how much? IS by IP. Already I wrote the relation. If you divide them, you can also write NP by NS. This is called a very, very important principle. This is called principle of transformer. Principle of transformer. Next one, efficiency of the transformer. Every transformer is having less or more efficiency. Efficiency of a transformer. How will you represent efficiency of transformer with the symbol eta? So it is defined as ratio of output power by input power. But for ideal transformer, what is the efficiency? 1 or 100%. In the percentage, as he told, Kamalesh told 100%. But only in the efficiency means 1 only. Okay. For idealized transformer, output power equal to input power. Na? So what the efficiency value? Must and should be 1. In the percentage, what the efficiency percentage equal to? Should multiply with the 100%. But anyway, practically it is not possible. Na? How much power you will give in the primary coil? Same power you cannot extract at the secondary coil. Okay, but for a real transformer, output power is always less than input power. Understood? So it is always less than 1 only. Means it is always less than 100%. Say sir. No? So that is all about the step-up transformer. Second one, again I will revise for step-up transformer. What are the major conditions? Tell me. Number of turns in secondary coil must and should be more than number of turns in primary coil. EMF developed in the secondary coil is more than EMF developed in primary coil. But reverse will come for current. Current is reciprocal, na? So current in secondary coil is less than current in primary coil. These are the required conditions to construct a step-up transformer. So reverse conditions, reciprocal conditions will be for step-down transformer. What you are seeing in your day-to-day life, all are step-down transformers only. In your street, and in power substation, everything. Understood? How will you draw the step-down transformer? Tell me. One primary coil. Primary coil. Very good. More number of turns for inductor coil. Whereas in the secondary coil, very less number of turns. Sorry. So current is IP. Here current is IS. EMF induced is EP and here EMF induced is ES. Number of turns are NP and number of turns are NS. Which is greater? Number of turns in primary coil is more than number of turns in secondary coil. EMF induced in primary coil is more than EMF induced in secondary coil. But current is less than current in secondary coil. Okay, that is the story of the transformer. That's it. Okay, note it. Yeah, practice. Jiva. Turn off that light. This light, left light. One only. Okay, no? Okay, now you people tell your story. What is our last topic? Did you remember? Huh? AC generator finished. Then over. Electromagnetic induction is over. Okay. Okay. Write little bit faster. Okay, so now we will enter into our next chapter, alternating current. Alternating current. Very, very important. And this is a very smallest chapter and very easy. Okay. What is the meaning of the alternating current? The current which changes in magnitude as well as direction also. Sometimes both magnitude as well as direction also changes. Such type of current is called what here? Alternating current. So some examples for alternating current. If you take I is equal to 2 into T. As time changes, current also changes. See this I is equal to 2 into sine 2 pi into T. Here time changes, current also changes. The current which is depending on the time. So automatically its magnitude changes and also direction also changes. Is my point clear? That is the alternating current. In major all electronic and electrical component, we prefer alternating current only. The current that is produced in power production center, to bring it to city, we have to convert into alternating current. What is the reason? What is the difference between direct current and AC current? If you see any direct current from the battery, that electron will completely travel throughout the wiring. But alternating current means what? Alternating current means throughout the copper wire, all electrons are accommodated like this now. Yes or no? For example, you want to construct one house. Here some bricks are there. How will you transport to this place? If one labor, one person completely carrying the bricks and walking from here to here, he will easily getting tired, no? Correct or not? After 4-5 trips only, severely, he will lose lots of energy. So more labor required, lots of amount will be wasted. Instead of that, all that 10 labors will stand like this. Are you understanding? Have you noted if any labors are during the construction work, have you noticed they will stand in this row. Just they will pass the bricks from one person to another person. So they don't need to walk from one place to another place. So they have saved lot many calories. Correct or not? For long hours, they can work. Correct or not? Same way, what is the role of the electron? The chemical energy stored in the cell has to give to the bulb, no? Correct or not? When it is walking from here to here, the type of current is called which current? Direct current. Understood or not understood? I mean the electron completely displacing from one place to another place, and it is giving its kinetic energy to the electrical consumer like bulb, washing machine, etc. But in AC current, not like that. Just they are doing simple harmonic oscillations between this position and this position. When they are striking the neighborhood electron, it transmits its maximum kinetic energy. Like that energy from one electron to another electron, one electron to another electron, finally it will reach to consumer, bulb or washing machine. That is the best advantage of the alternating current. Understood or not understood? Here in the direct current, if you see, in case of the direct current, this electron has to encounter lot of collisions with copper atoms. Na? Kindly say yes or no. In the form of friction, where there is a friction, lots and lots of energy will be dissipated in the form of heat. But in the alternating current, not like that, no. In the alternating current, what will happen? Simply the electron will do the simple harmonic oscillation between just left extreme position and right extreme position. Are you understanding? That's what, which transportation is benefit for you? Alternating current. Have you noted? They will write during the power transmission wires, they will write 40,000 volt. One danger symbol is there. AC they will write. Mean that is a alternating current. During any power transportation from power substation to power station, power production center to our houses, all are AC current only they will transport. Once it is entered into our houses, our equipments required direct current. Understood or not? That's what there is a adapter which will convert AC to DC. Is my point very clear, everyone? Understood or not understood? AC only. AC generator, na? In the power production center, what the current is produced by generator is alternating current only. Separately, you don't need to convert into alternating current. Understood? Okay. Now, but how to measure the current? As the current is continuously changing its magnitude and direction, how to measure the average current? How to measure this alternating current? Okay, there are some techniques are there. Some techniques to measure alternating current. To measure which current? Alternating current. Alternating current. Say sir, no. For example, there are various techniques are there. First of all, mean current or average current. What is the first one? Tell me what is the first type of current? Mean current or average current? Mean current or average current? For example, I am taking one generally used alternating current. So current equal to peak current into something sine omega t. What the I naught is called here? Respond. Peak current. Peak current. What is the omega? Angular frequency. Angular frequency. Just now I told this current is contributed by oscillations of electron, oscillations of charges. How will you define angular frequency? Number of oscillations made by the electron is called what here? Angular frequency. Understood or not understood? So omega is called angular frequency of the electric current, AC current. So if you plot the graph of current, time always I should plot on y-axis. Current always I have to plot on y-axis. Time always on x-axis. Current is always on y-axis. I think you people know sine graph very well. This is a positive sine graph, na? How will you get the graph? Like this sinusoidal graph you will be getting. Understood? One electron completed one oscillation from mean position to right extreme position, then right to mean, then again right to left extreme position, then again coming back to mean position. Within this time, one full wave, one full cycle is produced. When electron completed half of the oscillation, it will produce half cycle. When it completed one oscillation, it will produce one full cycle. Understood or not understood? Kindly say yes or no. So here, have you noticed in the first half cycle, current is always having positive values, no? Current is positive means always in the circuit it is revolving in the anti-clockwise only. But after completion of the positive half cycle, current become negative, no? What the meaning of negative? Current will become clockwise direction. Okay, so this maximum value of current is called peak current. This is also peak current. I hope you people understood very, very well. Kindly say yes or no. Understood? Okay, that is the total current after t seconds. Such kind of currents variable. How to measure? I will explain. General formula for mean current. Kindly tell me what is average speed formula. Tell me. Total distance, not distance. Total distance by total time taken. Total distance by total time taken. But what is the average current meaning? How will you write? Tell me. Total charge by total time taken. Total time taken. What a total charge? Tell me. Integration of I into dt only, na? In the electric current I introduced total charge how much? Integration of I into dt. Small charge flowing in a very little time, how much? I into dt, na? Total charge means what? Integrate on either side. But a total time meaning integration of 1 into dt. This is a general expression for and very, very important expression for which current? Average current. That is how much integration of I into dt by integration of how much? 1 into dt. Everyone kindly remember at your fingertips. In your IIT direct questions will come. Understood? Now, I want to find average current. Average current over a full cycle. Average current over a which cycle? Full cycle. What a time taken to complete one full cycle or one oscillation is called? Time period, capital T. But time taken to produce half of the oscillation is T by 2. Understood or not understood? So substitute the I value. Tell me what the average current equal to? Integration of I value how much? Tell me. I naught into sin omega t into dt and whole divided by integration of 1 into dt. Over a full cycle meaning time, initial time 0 to capital T. Very good. Here 0 to here capital T. Peak current is always constant. Na? I will take it outside. And what is the integration of sine of omega t? Remember always 0 over a full cycle. Anyway, I will prove it. But integration of 1 into dt, small t, put the limits from where to where? 0 to capital T. If you simplify, what is the average current? I naught into, but integration of sine omega t minus cosine omega t. In the denominator, you have to differentiate this. So omega will come and whole divided by, put upper limit first, means t minus 0. Here also put the limits from where to where? 0 to t. So the average current equal to how much? Minus I naught by omega, bracket start, cosine omega into t minus cosine 0 and whole divided by capital T. So minus I naught omega into t and bracket will start cosine omega value how much? 2 pi by t into capital T minus cosine 0 value how much? 1. Dt cancels out and minus I naught by omega into t. What a cosine 2 pi value? Cosine 360 value how much? Plus 1 only. So 0. That is the drawback of the average current. Understood? Why drawback? Total charge is 0, no? Over a full cycle, the area under current versus time graph is representing charge only, na? Here charge is, for example, plus 10 coulomb means here charge how much? Minus 10 coulomb. So net charge how much flowing in the full cycle? 0. That is a drawback of the average current. Understood or not understood? That's what average current will not be used over a full cycle. Understood? Copy quickly. Average current over a full cycle. Hereafter, one very important note, students. Kindly remember, sin omega t or sin 2 omega t, average value how much? 0 over any full cycle. Over any full cycle. Why? Because always doing integration is very difficult. So you people have to remember this trick. But integration of sin omega t or cosine omega t or sin 2 omega t, sin 3 omega t, cosine 3 omega t value always 0 only. Understood? Copy quickly. Kamlesh, put that AC cool mode 21. It is not working. Not there. It will show like that. Mode is there, no? Mode, put cool mode. Come this side. Sensor will be, I think, right side on. Cool mode and 21, enough. Turbo off, turbo. That's what average current is, not useful to measure the current in full cycle. Understood? Copied? Who copied? Find average current in half cycle. Finished? Okay. Wrong. Okay. Look it out here. Average current or mean current over a half cycle, over any half cycle. Kindly tell me what is the formula? What is average current formula? Integration of I into dt by integration of 1 into dt. You should remember at your fingertips. I value how much? Respond. I naught into sin omega t into dt by integration of 1 into dt how much? T from where to where? 0 to t by 2. I naught peak current constant always. I will take it outside. But integration of sin omega t, very good, minus cosine omega t by omega. This omega t in denominator you should differentiate. You will be getting omega and whole divided by put upper limit. So t by 2 minus 0. Understood? So what is the average current value here? 2 into I naught by capital T and minus omega, and what is the cosine omega t value? From time where to where? 0 to t by 2. Understood? So what is the average current equal to? Minus 2 I naught divided by t value how much? 2 pi by omega into omega. Put upper limit omega into t by 2 minus cosine omega into 0. Say yes or no? And omega cancels out, 2 cancels out, minus I naught by pi. Cosine omega value how much? 2 pi by t into t by 2 minus cosine 0 is 1. 2 gets cancelled, tt gets cancelled. So minus I naught by pi. Cosine pi nothing but cosine 90 plus 90 minus 1. Very good, minus 1. So 2 I naught by pi. Kindly everyone should remember this value at your fingertips. This is called what here? Average current over a which cycle? Half cycle. Over a half cycle. Not only current, EMF also. What is the average EMF over a half cycle? Average EMF over a half cycle, how much? 2 into E naught by pi. Understood, students? So average current, average EMF over a half cycle. Very, very important values. Kindly remember. Copy quickly. So tell me, are you supporting average current? Average current is totally failed, no? Tell me why totally failed? It is not useful to measure full cycle. Perfect measuring instrument means it should have a non-zero value over a full cycle. That's what we will leave this average current. No instrument is used to allow the average current. So we'll find one alternative type of current. What is the type of current is called? Mean square current. Which current? Mean square current. Mean square current. That is denoted with the symbol IMS. How many operations you have to do? Mean operation, square operation. No? Next it will come slowly. That is third type of current. This is the second type of current only. Understood? Okay, so mean square current or average square current also. So you have to square it, then mean it. So what is the general expression for mean square current? Integration of I square into dt and divide by integration of how much? 1 into dt. Averaging means dividing with time. What is the meaning of averaging? Kindly respond. What is averaging meaning? Dividing with time. Dividing with the time. What is the second operation you have to do? Averaging I did. Squaring also I have to do, no? Say yes or no. I have done here. Squaring I have done. That is called mean square current. Understood or not understood? Now, I am going to find, shall I slide like this? Like this? You copied no, already? Now I am going to find mean square current, I mean MS current over a full cycle. Which cycle? Over a full cycle. Tell me, I can write mean square current. What is the formula? Integration of how much? I square into dt divided by integration of 1 into dt. Tell me what is the I value? Instantaneous current. I naught into sine of omega t. Substitute here. I value how much? I naught into sine omega t and whole power 2 into dt. And what is integration of 1 into dt? T from where to where? 0 to capital T. I naught square, with your permission, shall I take it outside? Kindly say yes or no. So I naught square, I will take outside. Integration of how much? Sine square omega t into dt. Put the limits from where to where? upper limit t minus 0. If a sine is square is there, you can't do anything, no? One formula is there. What is the cosine 2 theta value? 1 minus sine square theta. So sine square theta value how much? 1 minus cosine. Yes, sorry. Correct. So sine square theta means what? By 2 will come. So what I can write? Sine square omega t become cosine 1 minus cosine 2 omega t divided by 2 will come. Substitute here. So very comfortably you can do the integration. And mean square current equal to I naught square and integration of how much? 1 minus cosine 2 omega t whole divided by 2 into dt and whole divided by capital T. 1 by 2 with your permission, shall I take it outside? So I can write I naught square by 2 into capital T. Bracket will start. Integration of 1 into dt minus integration of cosine 2 omega t into dt. I don't need to explain. Just now I told many times over a full cycle, what is sine omega t value? 0. Sine 2 omega t value how much? Also 0. What is the average value of cosine omega t? Also 0. If you have doubt, you can check it, or simple logic. Cosine curve will be like this only, na? Over a full cycle, here how much positive charge is there, that much negative charge is there. So total charge is always 0 for cosine cycle, sine cycle. The technique everyone should remember. So this total value will be 0 only, na? Kindly please say yes or no. Without doing any integration, without wasting our time, directly I can take it 0, na? I can save at least 5 minutes time. Understood or not? Okay. So in exam hall also you should not do this kind of integration. Directly you have to sense it is 0. So if you continue the simplification, I naught square by 2t and integration of 1 into dt value how much? Small t, put the limits from where to where? 0 to capital T. So the mean square value I naught square by 2 into capital T into bracket start t minus 0. 1t cancels out. So what is the mean square value? I naught square by 2. This thing also very important, student. But it is not advisable thing. Why? Because I naught square is there, na? Very big values will come. Correct or not? Is it possible to construct any ammeter to measure such big values like 1000 ampere, 2000 ampere? I naught square is there, na? If 2 ampere is going, mean it will become 4. 20 ampere is going, mean it will become 400. Can you construct such kind of very big meter? That's what one more operation you have to do. That is root operation. Which operation? Square is over, mean is over. Now what I should do? Somewhat betterment is coming now with the mean square current. If you root it, you will minimize the value. So very easy to construct ammeter within 0 to 10 ampere like that. Are you understanding the concept of? So one more operation I will add. What is the name of that? Root mean square current. Copied, huh? I will shift the slide. No issue, na? Okay, no? Okay. So that's what. What a next type of current? RMS current. What a next type of current is? RMS current. How many modes of operando we have to perform here? Square operation, mean operation, additionally root operation. So what is the formula for this RMS current? First only I will do root. Next I will do square. Next I will do meaning or averaging. Already this value we sensed, no? I can also write in another format. Why I am keeping star mark? Tell me. For time pass, huh? No, you have to remember at your fingertips. So root mean square current means what? Integration of, root of mean square current. Understood or not understood? Already I found the value now over a full cycle. Come on, tell me what is the IMS value over a full cycle? Very good. I naught square by 2 over a full cycle. Substitute nicely. So what do you get the RMS current value? Under root of I naught square by 2 means RMS current value how much? I naught divided by root 2. This value is also everyone kindly remember at your fingertips. Similarly, what is the RMS voltage? Kindly respond. What is RMS voltage? V naught by root 2. Okay. So that's what finally to measure the alternating current, which thing we have to use? RMS current. Whatever the instrument is you are using, ammeter or voltmeter, those things will measure only RMS values. For example, one ammeter reading is some 20 root 2 ampere is there. What is the meaning of that? That is RMS value only. Understood? In this AC adapter, what it is written, you know, I will read it. It is very hot. It is written somewhere voltage, light is dim. Okay. It is written, for example, 250 volt AC and 50 milliampere. It is written. What is the meaning of that? RMS current is 50 milliampere. RMS voltage is 250 volt only. Understood or not understood? I mean, the power that you are supplying must and should be 250 volt and 50 milliampere. Then only proper charging is done to my laptop. Understood or not understood? That is the RMS value. Whatever the values are printed on the AC devices, I mean, alternating current devices are all are RMS values only. Understood? Go and check any electronic instrument or electrical instrument. They will write 230 volt AC. Mean that is RMS value only. Understood or not understood? Okay. So I hope you understood very well about these types of current. Now, one practice problem I'll give, that is your IIT question only. Try for 1 minute. I is equal to T square. Find RMS current. Find RMS current from T is equal to 0 seconds to T is equal to 4 seconds. Many times this kind of models will come in your JE. Easily you can attempt. 1 minute time I am giving. You just work out and tell your answers. Don't tell I naught by root 2. Understood? Huh? T is the time. I current depends on the time. You have to find the RMS current. Between what time and what time? 0 seconds to 4 seconds. It is your previous year JE question only. So it is a time to show your application skill. Do with strong confidence. Yes, I can do. Just now, sir explained concept. Formula also nicely decorated with star. I will do that like that you think. But don't tell me I not by root 2. It hurts. Okay. Huh? When you have to use I naught by root 2, for I naught sin omega t only, you have to tell that answer. Understood? Huh? 64 ampere. Okay, Kamlesh is saying 64 ampere. Everyone have to answer. This kind of simple problems you have to grab easily. Cross check, Kamlesh.
Uh, 16. 16.
16 ampere. Changed, huh? Venkatesh is 16. Okay. Okay. Now time allotted over 1 minute. It should not exceed. Tell me, what is the RMS current formula? Under root of integration of I square into dt by 1 into dt. I value how much? Substitute. I value t square, again power 2 into dt whole divided by t. From where to where? 0 to 4. So again, right, IRMS current value how much? Integration of t power 4 into dt. I will put the limits from 4 minus 0 and under root of t power 4 value how much? T power 5 by 5. Put the limits from where to where? 0 to 4 and whole divided by 4 minus 0. So what about the RMS current equal to? Under root of 5 4s are value how much? 1 by 20. Put the upper limit 4 power 5 minus 0 power 5. 4 power 5 value how much? 4 4s are 16 and again 4 4s are 16 into 4 will come divided by 20 also will come. 4 1s are 4 5s are. So the answer is 16 by root 5 ampere is your answer. Venkatesh biscuit, Kamalesh also biscuit. Or where you committed mistake, tell me.
Forgot 5, sir. Root 5.
Okay. Mine is okay only, na? Correct only, na?
Yes.
Okay. Understood. It is not a tricky problem. No creative thinking is required. Direct formula only. Just max calculus should be strong. That's all. Okay. I hope you understood very well. Okay. So one question of the day I will give you. Just try in your house. I is equal to 2t. Find average current from 0 to 2 seconds. Find also mean square current also from 0 to 2 seconds. Third one, RMS current also. Now will you find but don't give incorrect answers. It hurts. Okay. It's a DAFA problem only. Find average current. Who will guide me average current formula? Vishwanath has to tell. This is not full cycle or anything. It is not a sinusoidal current. It is this one only. Everything same only. Average current. Who will tell? Very good. Integration of I into dt by integration of 1 into dt. Very good. That is a major conceptual formula. First answer, 1 minute only. 1 minute meaning your time out. 1 ampere. Huh? Average 1 ampere. Okay. Kamalesh and Venkatesh. IMS, second one. Okay, 4/3 ampere. Kamalesh. Everyone should maintain minimum speed because to crack IIT, speed important. 16/3 ampere. Venkatesh, average. Okay, for Vishwanath, 2 ampere. Visu 2 ampere. Average 1 ampere. Kirutika. What Kalpana, madam?
2 ampere, sir.
Average current 2 ampere. Huh? Okay.
RMS 4/3.
RMS 4/3. Venkatesh.
RMS 3/3.
RMS is root 3/4 means 2/3 only, na? Root 4 means 2/3. Okay. Now it is my turn. It's the time to check out average current. What average current formula? Integration of I into dt by integration of 1 into dt. I value how much? 2 into t into dt by integration of 1 into dt how much? T. Put the limits from where to where? 0 to t. So 2 I will take it outside and integration of t into dt from 2 minus 0. 2 to Katam. What integration of t? T square by 2. Put the limits again from 0 to 2. 1/2, 2 square minus 0 square. So 2 ampere is the right answer. Who told? Vishwanath. Very good, very good. Once give a small round of applause for Vishwanath. Loudly. I think Kalpana also, please appreciate. She also told 2 ampere. You are killing mosquitoes or clapping, right? Huh? Okay. Now second answer. Second answer, tell me how many you found? Only Kamlesh told.
Left side.
16/3. Huh? Okay. Tell your answers. Now I started doing. After that, not valid. Your answers are not count. Okay. Who will tell me 16 by AMS 16/3? 16/9. Huh? 16/9 is Kamlesh. You said already 4/3, no? Changed, huh? Okay, 4/3 again change. 2 answers changed. Okay. So what is the second answer? Mean square current formula how much? Integration of I square into dt by 1 into dt. I value how much? 2t whole power 2 into dt. Integration of t. Put the limits from where to where? 0 to t. And 2 integration of how much? T square into dt from 2 minus 0. 2 cancels out. T square integration how much? T power 3/3. Put the limits from where to where? 0 to 2. And 1/3.
2t means 4 only now. 2t the whole square is 4.
Oh, sorry. Printing mistake. Here 2 will be continued, no? Here also 2 will be continued. 2 power 3 minus 0 power 3. So how much? 16 by 3 ampere. Who told? Ah, very good. Once everyone give small round of applause for Venkatesh. This is clapping. This is ego. Clapping with ego. Understood? Okay. This is clapping. Okay. Should have a great heart to clap because that is a appreciation. Once you appreciate, you will get it back again. Very good. Wonderful job, Venkatesh. Third one. What is the third one? Tell me. IRMS current. Mean under root of IMS only, na? Means under root of 16. But very good. 4 by root. Again. Very good. This is Kamalesh. Wrong. Okay. Now, very immediately, we will move to next concept. That is very important. That is a pure inductor. Listen carefully, student. This somewhat confusion will come hereafter. But if you focus maximum, very easy only. Kindly focus. Okay, pure inductor with an AC source. With an AC source. Only full memory work is there. Some tricks I will tell. That's what. Please pay your maximum attention. I am taking one pure inductor. Pure is possible, huh? Nothing is pure, no? If you take a solenoid, less or more, some internal resistance is there, na? Kindly say yes or no. That's what this is a ideal or imaginary situation only. Ideal or imaginary. To understand the inductor properties, AC source only I am explaining. That's behavior of inductor. To allow the current, what I have done, this is a AC source symbol. AC source means sine current only I am using, na? That's what sine graph I am keeping inside. Come on, tell me what the EMF applied to the inductor? Sine graph means E naught into sine omega t only, na? What is omega meaning? Number of oscillations completed by the electron in 1 second. What is E naught value? Peak EMF or maximum voltage applied by the cell. Okay. At any time t seconds, how much current is flowing in the circuit? I amperes of current is flowing circuit. Current is always flowing from high potential to low potential. This is also high potential to low potential. Shall I use loop law? Loop law from A to B, then B to A. What is loop law? Kindly tell me. Sum of all voltage drops how much? 0. When I am walking from A to B, what is the voltage drop across inductor? I am walking from high potential to low potential. So minus I have to keep. What is the voltage developed across any inductor? L into di by dt only, according to Faraday's law. Then I am walking from B to A. Means low potential to high potential I am walking. So plus E naught sine of omega into t. Understood or not understood? Okay. Now, what are the variables? Current is variable, time is variable. Basic sense of max. Current left side, time right side I have to shift it. So I will write minus L into di by dt is equal to how much? Minus E naught into sine of omega into t. Minus minus cancels out. So di by dt equal to how much? E naught by L into sine omega into t. This dt, scientifically it should be right side only, na? Where t resides, there dt also should reside. Understood or not understood? So this is only small change in current in a very small time interval. I want total current. What I should do? Integrate on either side. What integration of 1 into di? I. What integration of sine omega t? Very good. Minus cosine of omega t. In the denominator, one more time you should differentiate so that the omega will come. Okay. So what is the current after t seconds? I is equal to E naught by minus E naught by omega into L into cosine of omega t. With your permission, shall I write minus cosine omega t as a EMF is sine term, no? Current should not come in cosine term. Immediately I will change into sine term. So sine omega t minus 90 will come. 90 minus omega t means plus cosine omega t will come. But I need to obtain minus, na? So sine omega t minus 90 I have to get. So tell me how much EMF you applied? E naught sine omega t only, na? This is called phase of the EMF. What is the phase of the EMF? Omega into t. What is the phase of the current? Omega t minus pi by 2. So current is leading or lagging? Minus pi by 2 meaning lagging. So this is a very, very important note. I will elaborate what is the lagging, what is the phase. I will explain everything. Important note. Where inductor is there? In inductive circuit, which thing is lagging? In inductive circuit, current is lagging. Current is lagging EMF by how many degree? 90 degree. What is the meaning of that? I will explain. 90 degree lagging meaning, I will treat this EMF as a vector. I will treat current also vector. Or phasor also I can call. What is that? Phasor. Why I am calling phasor? The vector, I mean this current vector always rotating. Phasor meaning rotating vector. What is that? Rotating vector is defined as a phasor here. If you plot the current as a vector format, it is minus 90 degree. Na? Minus 90 degree means this is x-axis. We always take as a reference axis. Na? Minus 90 means this is only current. No? Clockwise means negative sign. Na? Minus pi by 2 meaning. Understood or not understood? Minus 90 means what, my dear students? Clockwise angle from positive x-axis you have to plot. This is called what here? Current phasor. The length of this current is called peak current or maximum current. Now tell me, how will you write this EMF phasor? Omega t plus 0 is there, no? Omega t plus 0 means it is lying on the x-axis only. That is called EMF phasor. What the length of this vector is called? Peak EMF. Understood? What the name of this diagram is called? Phasor diagram. Phasor diagram. Meaning is very simple. What is the phase leading and lagging? I will explain. EMF is sine omega t, no? So how will you plot the graph? Like this only, na? Kindly say yes or no. EMF here and time here. What about current? It is a negative cosine, no? Negative cosine means it will start from like this only, na? Kindly say yes or no. This is the current versus time. I mean, this is a negative cosine curve. What is this curve? Positive sine curve. Now you will understand the You are using phone, Avishana? Call. Which file? Now focus, right? After this, you do what you want. I told night is very important. Okay. No, don't say sir that, but listen, my worry. Okay, you will lose simple marks from this chapter. Okay. Now we will try to understand what is the meaning of lagging of current. Have you noticed when EMF is maximum, current is zero, no? EMF is zero means current is positive maximum. EMF is negative maximum means current is zero. That is the meaning of that. Understood? Same phase means what? EMF and current same phase means what? EMF is maximum means current also maximum. EMF is zero means current also zero. EMF is negative maximum means current also negative maximum. That is the meaning of same phase. 90 degrees current is lagging meaning what? What is that value? EMF is positive maximum means current will become zero. EMF is zero means current is how much? Positive maximum. That is the concept of current lagging 90 degrees to the EMF. Understood? In the any circuit, when you see inductor, immediately how to plot phasor diagram? EMF is always like this, current always lagging behind this like this. Understood? Now, how much EMF I apply? Tell me. E naught into sin omega t. How much current flowing in the circuit after t seconds? This only, no? E naught by omega into L into sin omega t minus pi by 2. This is nothing but peak current in the circuit, no? Correct or not? But E naught value? Peak applied EMF. Peak applied EMF. What is the peak value of current? Tell me. What is the peak value of current? Come on, respond. E naught by omega into L. According to Ohm's law, what a peak current equal to? Applied EMF by resistance only, na? Means the denominator representing opposition given by inductor. When original current is increasing, the inductor will try to decrease. When original current is decreasing, it will try to increase. That reverse behavior is called opposition. That opposition of inductor is called reactance. So this denominator term is called what here? Inductive reactance. If you pronounce resistance of inductance also, nothing will happen. But resistance meaning which leads to wastage of energy, na? That's what you should not pronounce as a resistance of inductor. Instead of that, what you need to use? Inductive reactance. Inductive reactance. Okay. So that is denoted with the symbol XL equal to how much? Omega into L. Everyone should remember at your fingertips. Understood? Say yes or no? Okay, kindly copy quickly. Copy it down. Yeah. I should share. Okay, students. So now you can leave. Tomorrow I will explain pure capacitor with AC source, pure resistor with AC source. Again mixing impure inductor, impure capacitor. Thank you. Thank you, students. We will meet tomorrow. Have a nice night. Bye. Day finished, na?